젠슨항이 한국에 한 번 더 옵니다. 이제 그러면서 만나는 기업들 리스트를 보면은 다 이제 피지컬 AI와 관련된 기업들의 회장님들을 만나게 돼요. 그만큼 이제 엔비디아 입장에서는 이제 피지컬 AI 시대가 거의 다가왔다. 뭔가 좀 더 마무리를 하기 위해서 더 다지는 미팅을 한다라고 생각해 볼 수 있거든요. 그러면 이제 피지컬 AI 쪽에 대한 투자 인기가 다시 한 번 더 올라갈 수도 있을 거고, 뭐 당장 단기적으로 인기가 오지 않는다 하더라도 결국 엔비디아가 선택한 건 뭐냐면은 엔비디아 GPU 다음으로는 피지컬 AI 시대가 열릴 것이다. 뭐 우리도 다 알 수 있는 거죠. 아시아 쪽이든 뭐 북미 쪽이든 다 이제 인구의 노령화로 인해서 제조업에 일할 사람이 부족해질 거고, 거기에 일할 사람을 대체할 수 있는 거는 로봇밖에 없다라는 걸 알게 됩니다. 거기에다가 자율주행도 해야 되죠. 이제 뭐 국방도 맡겨야 되죠. 이제 사람이 부족해지기 때문에 그걸 대체할 수 있는 게 로봇, 휴머노이드 로봇으로 점점 진화할 것이라고 예상해 볼 수 있는 겁니다. 그래서 대부분의 이제 로봇 스타트업들을 보면은 휴머노이드, 사람 모습과 똑같은 형태로 만들었습니다. 공장에서 일하고 운전하고 집에서 가정일을 돕고 최적화될 수 있게 만들어 놓은 거죠. 그래가지고 제가 미국에 가서 휴머노이드 로봇 회사를 투자하기 위해서 방문을 했었는데요. 단순히 방문하고 인터뷰했던 영상만 찍는 것보다는 제가 왜 가려고 했었는지, 그리고 거기에서 제가 어떤 것들을 보여드리고 싶었는지, 그리고 어떤 질문을 받았고, 그리고 그 이후에 나온 재밌는 결과가 하나 있습니다. 그것까지 이야기해서 로봇 회사를 투자할 때는 이런 관점으로 봐야 되겠구나 라고 생각해 보시면 좋을 것 같아요. 마침 이제 제가 방문했던 기업은 상장된 기업이 아니기 때문에 뭐 여러분들 뭐 주식 투자에 연관은 없을 수 있지만, 이런 방법으로 기업을 바라보고 CEO한테 질문을 하고 투자를 하는 거구나 라는 거를 보시면 좋을 것 같습니다. 그래서 제가 이번에 본 것들을 이야기하도록 할게요. 우선은 로봇 회사가 미국에 6개 정도가 있습니다. 제가 생각했을 때는 테슬라가 제일 유명하니까 우리가 투자할 수 있는 회사긴 하지만 전기차 사업이 대부분이고 로봇에 대한 이 프리미엄은 섞여 있어요. 그래서 순수하게 휴머노이드 로봇에 투자하고 싶지만 투자할 수 없는, 애매합니다. 실제로 투자하려면은 옵티머스밖에 없겠죠. 또 하나는 보스턴 다이나믹스예요. 기술력이 상당하고 또 이 회사가 소프트뱅크를 또 거쳐서 이 현대차로 들어가게 됐죠. 이 현대차의 자회사가 돼 있고, 이 보스턴 다이나믹스가 미국에 상장하게 되면은 현실적으로 매출 비중이 순수하게 휴머노이드 로봇에 집중된 회사이기 때문에 미국 시장에서 인기를 많이 얻지 않을까라는 생각이 드는데, 제가 들었던 고민은 뭐냐면, 그런데 이미 벌써 시장에서 평가하는 가격이 저렴하지 않다라는 겁니다. 대략 우리 돈으로 한 30조 원이 넘는 거로 예상되고 있는데, 그렇게 되면 조금 더 저렴한 거 없을까? 이렇게 찾게 된 거죠. 거기에 나머지 회사들 4가지가 있었습니다. 피규어 AI, 최근에 로봇에서 택배 물류를 정리하는 거를 100시간 넘게 하는 걸 보여주면서 인기를 끌었던 회사인데요. 문제는 여기도 비상장이지만은 기업 가치가 제가 생각하는 것보다 조금 더 높았습니다. 그 외에 나머지 3개 회사들도 있었고, 여기서 제가 이제 방문했던 회사는 ft.Foundation.Bot이라는 회사였었습니다. 여기는 이제 다른 회사와 다르게 국방에 대한 매출과 계약들이 있었기 때문에 이게 좀 더 독특했었어요. 그래서 만나봤었던 거고, 실제로 다른 기업들 대비 밸류가 저렴한 편에 속해서 여기를 먼저 만나보고 실제로 투자한다면은 여기가 조금 더 가치 평가가 되지 않겠는가 라고 생각해서 미팅을 하게 됐던 겁니다. 실제로 이 밸류에이션을 보시면은 피규어 AI 39빌리언 달러, 그리고 지금 보스턴 다이나믹스 15빌리언 달러인데 20빌리언까지 얘기가 나오고 있습니다. 그리고 그 나머지 기업들은 5.5빌리언, 3빌리언, 2빌리언 정도가 되는 거죠. 그러면은 기술의 격차가 얼마나 되길래, 또는 지금 판매량이 얼마나 되길래, 매출이 얼마나 되고 이익이 얼마나 되길래 이렇게 기업별로 서로 시가총액의 차이가 나는 것인가, 이거를 한번 알고 싶었었거든요. 그래서 제가 본 자료들이 또 하나 있었습니다. 상용화 단계에 어디까지 갔는가를 봐야 되는데, 아직까지 휴머노이드 로봇 중에서는 양산을 찍은 회사가 없었어요. 그리고 파일럿 단계에 있는 회사들이 저렴한 단계에 있었고, 상업 배포까지 간 회사들은 몸값이 5배에서 10배 정도까지 올라온 상태가 됐습니다. 그럼 제가 봤을 때 기술적으로 이 격차가 엄청난 차이인가를 생각을 해봤는데, 실제로 이 회사를 만나고 CEO를 만나고 또 관련된 로봇 관계자들을 만나서 들었을 때 제가 내린 결론입니다. 남들이 내린 결론은 아니고 제가 내린 결론은 생각보다 큰 차이가 있진 않다. 기술의 격차의 큰 차이는 아니다라고 봤습니다. 그러면 기술 격차가 빠르다고 기업 밸류를 비싸게 제가 투자할 필요는 없다라는 거죠. 사업 전략이 오히려 우수한 곳에 투자하는 게 낫다라는 겁니다. 어차피 지금 이 시장은 선점 효과를 누리는 시장은 아니라 봤어요. 왜냐면 B2C 모델이면은 선점 효과가 중요한데, 지금은 B2B로 들어갈 겁니다. 얼마나 기업들에게 좋은 사업 전략으로 이 제품을 들어가느냐, 그리고 이 제품의 기술이 얼마나 우수하느냐. 100점을 원하는 게 아닙니다. 90점이라도 싸게 더 효율적인 비용을 낼 수 있다면은 B2B에서는 오히려 90점을 선택하게 됩니다. 그래서 제가 선택했던 것들은 이제 아무래도 이 파운데이션 봇이 조금 더 저렴하고 괜찮지 않았나, 이 기업을 방문하게 됐다라는 거죠. 뭐 다 만나보고 싶긴 하지만 그래도 제가 좀 선택하고 효율적으로 좀 문을 열어줄 수 있는 기업을 방문했던 거고, 운 좋게도 뭐 촬영을 하지 않는 조건으로 내부 연구하는 것들까지 보게 됐습니다. 그리고 이 CEO를 만나면서 제가 약간 좀 짓궂은 질문들도 많이 했었거든요. 기술적으로 어디가 난해해요? 지금 어디가 지금 막혔어요? 이렇게 되면 어떻게 할 거야라고 하는데 깜짝 놀랐어요. 약간 CEO들은 좀 뻥을 좀 치고 싶고 살짝 좀 허풍도 내고 싶고 하는데 굉장히 솔직한 사람이더라고요. 그래서 의외로 너무 솔직하다. 좀 더 자기가 조금 더 말을 부풀리거나 하면은 기업의 가치를 더 올릴 수도 있는데 굳이 그러지 않고 진솔하게 말을 하려고 노력했고 실제로 진솔하게 말하는 모습을 보면서 CEO도 마음에 들었습니다. 그리고 이 기업들의 특징들이 하나씩 있는데 테슬라, 옵티머스는 뭐 너무 잘 알려져 있죠. 수직 통합으로 돼 있고 일론 머스크가 있기 때문에 그래도 잘하지 않을까? 가장 앞서지 않을까? 모두가 기대하고 있는 회사 중에 하나고요. 또 하나는 피규어 AI는 뭐 최근에 보여준 영상만 보더라도 야 너무 괜찮은데? 잘하고 있는데? 라고 하는데 제가 느끼는 거는 마케팅을 잘한다는 생각이 들었어요. 아직까지 뭐 양산을 한 회사는 없기 때문에 양산을 하고 나서 그 기술력을 인정받을 수 있다는 생각을 하고 있습니다. 그래도 꽤 앞서 나가고 있는 회사죠. 그 다음은 앱트로닉이라는 회사인데 여기도 매력적인 회사인 것 같아요. 근데 조금 더 한번 더 알아볼 필요가 있겠죠. 그리고 애길리티 로봇이라는 회사도 있는데 여기도 이런 장점이 있고요. 파운데이션 봇이라는 회사도 있는데 여기는 팬텀이라는 로봇이에요. 고위험의 환경이 특화되어 있으니까 아무래도 조금 더 사람을 대체하는데 제일 먼저 오지 않을까, 시장성이 제일 높지 않을까라고 했던 거고, 여기는 렌탈을 또 합니다. 다른 사업 전략을 냈죠. 근데 한국 사람들은 압니다. 정수기를 렌탈로 많이 했고 실제로 성공했잖아요. 아니 돈 주고 쓰면 되는데 왜 렌탈해? 근데 자동차 보면 다 할부 쓰고 있고 렌트 쓰고 있고 정수기도 렌트하고 있고 최근에는 침대 매트리스까지 렌트하고 있는 세상 아닙니까? 그런 거 봤을 때는 로봇도 렌트를 하는 게 더 나을 수도 있겠다. 기업 입장에서는 자본을 투하해서 감가상각으로 떨구는 것보다 차라리 렌트로 하는 게 비용 처리하는 게 더 효율적이거든요. 기업 회계적으로 봤을 때는 이게 더 낫다는 생각을 했는데 실제로 이 CEO가 관련된 회사를 한번 운영했던 경험이 있어요. 회계적으로. 이거 보면서 사업 전략 잘 잡았다 싶었었죠. 그리고 가장 큰 거는 에릭 트럼프가 투자를 했습니다. 대체 왜 그랬을까? 이래서 좀 더 호감이 갔었어요. 물론 제가 갔을 때는 에릭 트럼프가 투자를 안 했고 제가 이 기업을 보고 나서 인터뷰한 다음에 에릭 트럼프가 투자했다라는 거를 뉴스로 보게 됐습니다. 그래서 야, 에릭 트럼프의 선택과 내 선택이 같았었나? 라는 생각이 들게 됐었죠. 그 다음에는 보스턴 다이나믹스. 너무 좋아요. 너무 잘하고. 근데 이제 제가 생각하고 있는 기업 가치가 좀 더 비싼 편에 속하기 때문에, 그리고 제가 여기를 투자할 수 있는 공간이 나오지 않을 거다 싶어서 여기를 방문하지는 못했습니다. 자, 그래서 이 투자한 리스트들, 기업을 투자할 때 이 회사에 누가 투자했어도 굉장히 중요합니다. 미술 투자할 때도 보면은 이 미술 제품에 어떤 사람들이 샀었던 이력이 있느냐도 그림 가격이 올라가는 데 영향을 주거든요. 특히 비상장에서는 어느 회사가 투자했는지를 보면은 기술적 검증이라던가 CEO에 대한 검증이 어느 정도 됐다라는 걸 알 수 있다라는 거죠. 이런 걸 봤을 때 지금 있는 이 회사들은 모두 다 괜찮은 투자자들을 데리고 있다. 그런 점에서 어느 정도 기술적으로 또는 CEO적으로 신뢰할 수 있지 않을까, 이렇게 생각을 해봤습니다. 그럼 제일 궁금한 거는 에릭 트럼프는 대체 왜 파운데이션 봇에 투자했을까? 이게 제일 궁금했었거든요. 이 기업의 특징 하나는 뭐냐면 군용 로봇을 한다라는 거예요. 다른 회사들은 군사용 로봇을 하지 않습니다. 왜냐하면 휴머노이드에 집중하고 우리는 그냥 어떤 제조업 또 아니면 가정용 이렇게 만들겠습니다 라고 하고서는 이 국방과는 연계를 하려고 하지 않아요. 왜냐하면 그 자체가 좀 부담스럽다라는 거죠. 근데 오히려 파운데이션 봇은 과감하게 육해군과 계약을 하면서 이 군용 로봇에 대한 준비를 하고 있습니다. 자, 그러면 일반적인 로봇들은 가격 싸움을 해야 되고 군용 로봇은 얼마나 혹독한 환경에 견딜 수 있느냐, 그리고 이 내구성을 인정받았느냐, 그리고 얼마나 이 작전에 효율적으로 들어갈 수 있느냐고, 한 번 들어가고 나면은 계속 쓰게 됩니다. 장기적으로 고객이 되는 거죠. 그래서 방산 기업들은 PER이 조금 더 높습니다. 그런 점에서 파운데이션 봇이 성공한다면은 훨씬 더 높은 밸류를 받을 수 있겠구나라는 점 때문에 조금 더 긍정적으로 봤던 것도 있었던 거죠. 그래서 혹시 뭐 군용으로 뭐 하는 거 있나라고 한번 연구소를 돌아다녀 봤는데 그런 장면을 보여주진 않더라고요. 그래서 제가 눈으로 그것까지는 확인할 수는 없었습니다. 또 하나는 이 회사의 대표가 핀테크를 운영했던 경험이 있었어요. 그래서 핀테크 쪽으로도 이제 좀 관련돼 있고, 그러니까 이 사업을 가지고 단순히 로봇 사업만 한다는 게 아닌 거죠. 렌탈을 통해서 금융적 기법을 통해서 회사의 수익원을 늘리겠다라는 거고, 다른 회사들과 다르게 웬만하면은 이제 빚지는 걸 좋아하지 않더라고요. 최대한 풍부한 자금을 가지고 이 자금 내에서 빨리 수익화하는 목적을 가지고 있었어요. 최근에 오픈 AI랑 엔트로픽 보시면은 오픈 AI는 적자를 내다가 언젠가 우리가 시장을 다 먹으면은 크게 이득을 얻을 거예요 라는 전략이었던 거고, 클로드는 최소한으로 비용을 쓰면서 버티고 현금을 아끼다가 최대한 빨리 흑자 전환을 해서 자생적인 모델을 가지려고 했습니다. 근데 결국 시장에서 어떻게 평가했나요? 클로드의 몸값이 올해 가장 빠르게 뛰었었죠. 그런 점을 봤을 때는 지금 하고 있는 파운데이션.Bot CEO의 전략이 조금 더 시장에서 먹히는 전략이 되지 않을까라 보고 있고, 유동성이 좋을 때는 적자 내는 거를 충분히 투자자들이 감내할 수 있지만 또 안 좋은 시장이 올 수도 있잖아요. 그럼 그때 견딜 때, 데스밸리가 왔을 때는 그때는 또 이렇게 파운데이션.Bot 같은 전략이 훨씬 더 버티기 좋을 수 있다라는 생각에서 좀 길게 봤을 때 이 전략이 낫지 않는가 라고 생각을 하게 됐습니다. 그리고 여기 파운더들을 보시면은 이제 군 전문가도 있고요, 실리콘밸리 VC 전문가도 있고, 이렇게 창업을 했던 핀테크 전문가도 있었고요. 여기에 또 하나로 뭐냐면 에릭 트럼프가 여기 단순히 투자자로만 들어오는 게 아니라 최고 전략 책임자로 들어옵니다. 그러면은 에릭 트럼프가 여기에 들어와서 이 기업에 어떤 길들을 열어줄 것인가, 이게 하나의 관전 요소가 되겠죠. 그런 점에서 매력 있다라고 봤었습니다. 그리고 왜 국방에 올인하는가를 좀 고민을 해봤었어요. 경쟁자들이 안 들어오려고 합니다. 그냥 비워놓은 시장이에요. 들어와서 시장을 가져가면 됩니다. 그 점이 우선은 제일 유리한 점이라는 거고, 여기서 빠르게 수익을 내고 장기적인 우수한 현금 흐름을 만들어내는 주머니가 될 것이다, 이렇게 봤고, 또 국방 쪽은 가격에 둔감합니다. 비싸더라도 한번 인정받은 제품은 계속 쓸 수밖에 없고, 이 미국에서 인정받은 제품이 전 세계로 수출 나갈 수가 있어요. 우리가 미국에 있었던 뭐 탱크, 전투기, 군함들을 사서 쓰는 것처럼 이게 해외로 수출 나가는 모델이 될 수도 있을 것 같다라고 본 게 두 번째였습니다. 그리고 중국 견제를 위해서라도 지금 뭐 드론 같은 만 보다도 군집 드론으로 서로 막 경쟁하듯이 보여주고 있는 것처럼 휴머노이드 로봇도 결국은 이렇게 중국과 미국이 경쟁하는 모델로 가게 되면은 파운데이션.Bot은 미국 정부가 관리해야 되는 기업으로도 들어갈 수 있지 않을까, 이렇게 생각하게 된 겁니다. 또 하나는 이 렌탈 사업인데, 조금 더 설명을 드리자면 이게 한 대당 얼마까지 갈지 모르겠지만 뭐 예정치로 봤을 때 한 10만 달러다 보면은 이게 그렇다 하더라도 인건비보다 저렴합니다. 여기서 보다시피 뭐 유지보수도 해야 되고 여러 가지 있지만, 사람은 하루에 8시간 정도밖에 일을 할 수가 없어요. 근로법 때문에 뭐 더 할 수는 있겠지만. 그런데 로봇은 충전 시간 제외하고는 계속 일을 할 수 있습니다. 그리고 감가상각을 보통 회계상 4년 정도 잡는데, 그 이상으로 일하게 되면은 감가상각비를 다 떨군 상태에서 보너스 요소가 됩니다. 그래서 로봇을 잘 관리해서 쓰면 쓸수록 기업들한테는 훨씬 더 이득이 크지 않을까. 그러면 결국은 다 이렇게 휴머노이드 로봇으로 전환되게 되는 거고, 아까도 말했듯이 비용 처리를 위해서라도 이렇게 렌탈에서 쓰는 모델을 더 쓸 것이다. 그렇게 되면 렌탈을 하기 때문에 계속 반복 매출이 일어납니다. 그리고 데이터 소유권을 가지게 돼요. 만약에 제가 로봇을 주게 되면은 그 로봇에서 벌어지는 빅데이터를 제가 수합할 수가 없을 수 있는데, 렌탈이기 때문에 데이터 소유권을 가지고 있음으로 인해서 이 로봇의 발전을 더 빠르게 가져갈 수 있는 거죠. 빅데이터가 좀 많기 때문에. 그리고 이제 군 조달을 하는 거에서 군대 입장에서도 이 로봇을 사는 것보다 장기 계약을 맺고 예산 안에서 렌탈로 처리하는 게 훨씬 더 편리합니다. 그런 점을 봤을 때 이 파운데이션.Bot은 렌탈 전략이 되게 하나의 독특한, 앞으로 강력한 무기가 될 수도 있지 않을까, 이렇게 생각을 해봤습니다. 그러면 제가 인터뷰를 어떻게 했고 이 기업들을 돌아다녀 봤는지 여러분들이 보시면 좀 도움이 될 것 같아요. 그래서 제가 CEO랑 인터뷰했던 영상들을 이제 보여드릴 거니까요, 여러분들도 비상장 기업들, 테크 기업들은 이런 식으로 보고 이런 식으로 판단하고 투자할 수도 있겠구나 라는 거를 보시면 좋을 것 같습니다.
So what you're seeing here is the team is essentially collecting a lot of robot data. So part of building the AI stack, which we call Cortex, is majority of it you can just train with data on the internet, and then data of like humans doing different things. The last mile you want to train with the robots so that you have a good understanding of the embodiment. A part of that is every day the team does different kinds of tasks and collects some data. Our goal is to be able to collect a decent amount of just robot embodiment data, which again we call free play, very similar to how kids do it. They run around, hit themselves at the wall. Everything's like good data, which is even if you drop a part, it's good. Even if the robot hits a table, it's helpful. So a lot of that stuff happens here. This is Phantom 1, so it's our first robot that we built since May 2024, that's when we started. This robot, we were kind of like, I had low expectations. So in a long time, I wanted to do heavy industrial work, but I wasn't sure if the technology was ready to be able to do like full outdoor heavy industrial stuff. So Phantom 1, we designed kind of like as an amphibian, so it can do light industrial work, which we've deployed about 3 robots doing work in auto manufacturing, and then few robots for defense use cases. And so we tested and built this whole system. I'd call this like an early production unit, and the stuff we would blur out is Phantom 2, so that's the 2nd generation robot we're currently bringing up. Our goal is to build about 10 of those in Q2 ideally, and then start scaling production in Q3. That's essentially the mass manufacturable model. Much strong. It's taller than this, much stronger than this. Also waterproof, dustproof, has no wires, very large battery. So that's what's coming next. So that does all machining. So all of your surfaces and parts, yes. And then a lot of the sub-assembly happens up there in the assembly stations. And then everything, like all of the part marriage happens down here. So this is where we do final assembly. And then we take this back to the test bay and do end-of-line testing. So the test bay that I showed you, those are like data collection. If you look behind it, there are a bunch of robots that are right now being brought up fully.
이게 뉴 모델이고 언제 나오면 언제쯤인지 한번. 네.
Oh, this is still Phantom 1. The legs back there were from the newer model, and the torso would be ready hopefully next 30 days. So the full robot would be ready in like next 30 to 45 days. That's like the first model. Next month or 2, but then we're already starting to build the 2nd, 3rd, 4th. So we'll build about 10 of them in Q2. And then we'll do a design to manufacturing handoff. So this team then is going to take over and start building more of Phantom 2. All these kinds of tools that you put in, and like this is a good example, and you put aluminum, copper, steel, whatever in there, and it's kind of like a 3D printer. So it takes that and then builds parts like this, right? So, or this is like your linkages on your knees. So it builds all of those things.
제가 지금 파운데이션.Bot 회사에 와서 로봇을 보니까 너무 신선하고 새롭고 다양한 질문들을 여쭤봐야겠다는 생각이 들었습니다. 네, 자기소개 부탁드리겠습니다.
Yeah, for sure. Again, I'm Sanket. I am the founder and CEO of Foundation. I was born and raised in India, so kind of if you track all the way back my history, in North India actually. Grew up in a very academic family, so my dad's a doctor, my mom was a teacher, and kind of became, just had a natural inclination to technology and engineering. So I've been building things ever since I was pretty young, so like 12 or something. Came to the US when I was 19, I think, 19 or 20. Did my undergraduate in computer engineering, physics and math, and did my graduate school in electrical. I was also an astrophysics researcher, so I worked there I think about 6 years, and that's where I fell in love with computer vision. So being able to, like, to me it was very fascinating to just look at images and be able to make sense of them. So having computers make sense of the real world. Fell in love with that kind of, but didn't think the technology was at a place where you could do meaningful real world automation. But I thought the technology was at a point where you could do back office automation. So documents that people review in insurance and banking and all these different places. Decided to focus on banking, started my first company there, built and grew that over 10 years. Around the tail end of it, kind of like was really craving to get back into more core computer vision. And I felt like almost all the breakthroughs were at a place where you could do some really serious real world autonomy work, and decided to start Foundation. When I started the company, I was more so looking at what everybody else was doing, and it seemed like no one was that further along in humanoids yet, or what I call like just general purpose robotics yet. Decided that that's where I wanted to focus my time and energy, and it seemed like it's not that anyone was super further along that like I won't be able to catch up. But then on top of that, like to me the piece that was most exciting was I think we have this opportunity ahead of us where if we really build these technologies well, we by and large have one of the biggest problems that plagues humanity totally solved. Like, so poverty just generally disappears. And I think like if you can just build robots that can by and large do anything that happens. It seemed like a lot of people were focused on home use, so making your coffee, folding your laundry, things like that. I didn't think that, it wasn't that interesting to me because I don't think that's like a massive needle mover in the society in the grand scheme of things. Some people were working on light industrial. I thought maybe people were working on light industrial because like that's what the technology can do today. So I started Foundation with the goal of I want to do actually heavy industrial, so defense, construction, heavy logistics, things like that. Didn't know how feasible that was at the time, so we kind of had our feet in both light industrial and heavy industrial. And I started the company, and since then, obviously, we've gotten pretty deeply. We have high conviction on heavy industrial work. So I say majority of everybody else is kind of either building toy cars or sedans for humanoids. We're more so building pickup trucks. So that's kind of our focus.
그러면 이 로봇만 만드는 게 주력 매출인지 아니면 또 다른 또 매출 모델을 생각하고 있는지 좀 궁금합니다.
Yeah, I mean, so currently we lease our robots, so we don't really sell them, and we do that because we think in the current state there is a lot of support needed to be able to make these robots work in scale, because for the foreseeable future we're going to have to improve software, add more capabilities, collect more data, train more models. So we end up more so leasing the robots, and with that what you get is everything baked in, so repairs, training robots to do new things, all of that stuff. I do think that's more so in the near term. I think the long term, it would be very similar to kind of like how you have with cars. You're probably going to buy something, and there will be then subscription packets on top of that for various kinds of capabilities. But I think we're probably like 5 to 6 years away from a business model like that. I think for the foreseeable future, the most economically feasible model is going to be robot as a service. So that bundles in everything: software, hardware, maintenance, field operations, pretty much everything.
다른 회사들 보면은 판매, 그러니까 이 로봇을 판매하는 거를 많이 이제 보여주는데 구독형으로 전략을 잡은 이유가 좀 있을 것 같아요. 그걸 좀 듣고 싶습니다.
I mean, because again, our goal is to be able to support and maintain the fleet for you. So it's by and large zero effort. So adding new capabilities, so new tasks, repairs, all of that stuff, we just want to be able to handle. And we think that is probably the right way to provide these services to customers today. In the US, for instance, that works out quite well for our customers because you do get the robots today at a much lower cost than you would labor. So for the equivalent amount of labor, your cost is going to be close to the double amount that what you pay us. So for our customers, like they see payroll reduction pretty much right out the gate, and they pay us if we do the job well. They don't pay us if we don't, and that enables us to be able to kind of deploy this fleet in a way that it's successful versus just ship the hardware and then let the customer deal with what they need to do. We think this is a better way to be able to get the right value extracted for our customers out of the technology that exists today.
그러면 판매하는 전략은 초반에 현금을 많이 당길 수 있지만 나중에는 현금 흐름이 적잖아요. 근데 여기는 초반에는 현금이 좀 빡빡할 수 있지만 나중에 현금 흐름이 풍부해지면서 캐시플로우가 좋아지는 사업을 바라시는 건지 이런 것 좀 궁금하네요.
Yeah, pretty much. So the trade-off obviously is you don't get paid up front. Like our payback cycles are close to 12 months, but after that our margins are over 80%. So and the same hardware can be in the field for at least 6 to 7 years, which I think is like it pretty much has software like dynamics in the business, at least for this phase of the company. And this phase is kind of like we aim to deploy anywhere between like 100 to 200,000 robots at the most annually. I think the next phase we're going to deploy over like 500 to 1 million robots every year. I think that would see a massive cost reduction. I think in those business models would be probably more akin to how cars are sold today, which is you're going to buy for the price, and there would still be like an autonomy subscription that you would pay on top of it. So you'd still have some software revenue, but you'd probably just like end up selling the hardware and then recouping the cash. But for the near-term scale, this works quite well. The only exception to that rule is defense, right? So in defense, all the payment is upfront, and then we have a services contract that's separate. But for industrial customers, they found it to be, and we found it to be quite useful to just end up leasing the robot to them because it models quite well as like a payroll expense versus some kind of hardware procurement life cycle. So it's just more convenient and easier and lightweight for our customers as well.
보통은 이제 테크닉 위주로만 보는데 이렇게 파이낸스 전략까지 이렇게 생각해서 짜게 된 거는 혹시 예전에 뭐 창업 경험 중에 뭐 파이낸스 경험 있으시거나 뭐 그랬었던 것도 있는 게 아닌가라는 생각이 드는데 혹시 그때의 경험이 좀 도움이 됐는지도 좀 궁금합니다.
Yeah. Well, I wish I could take credit for it, but the subscription model is essentially my co-founder Mike, his idea and the experiences he had selling robots into Fortune 500s and corporates before Foundation. So Mike had another company called Cobalt Robotics, which was building security robots, and what they found over there was that hardware procurement life cycles were a death spiral. They take way too long, and if you would instead just try to augment into the payroll budget, you by and large move significantly faster in your sales cycle. So that was the premise of it. I am biased on as a service revenues. Last time I pretty much created this industry called banking as a service, so providing financial services as a subscription service to other fintechs to be able to build on top of. I'm definitely kind of like skewed towards that thinking as well, but you want to make those decisions first principles in terms of what's really right for the business. And the reality is right now, because these technologies are maturing on a very rapid clip on both hardware, software, and AI front, it makes sense to be able to have some kind of incentive structure that warrants the fleets for the customers getting really good very quickly. And what really warrants that is just having some, like, lease them versus sell them. Once there is, for lack of a better word, like stagnation, in the sense that like majority is already there right out of the box from the beginning, then I think just selling it would make a lot of sense. The second component of that is also cost, which is it costs us significantly more to build them today than it would in like a few years later when we have much higher unit volumes than we do today. So for all of those reasons, I think it kind of made sense to do some kind of subscription model, and it seemed like it kind of aligned the incentives of us and our customers quite well.
이 회사를 지금 그러면 설립한 지 얼마나 됐는지 좀 물어보시면 돼요.
I started the company in May 2024, so actually less than 2 years.
2년 만에 지금 보니까 로봇도 다 나와 있고 이 굉장히 빠른데 2년 만에 이렇게 빠르게 기술적으로 발전할 수 있었던 비결이 뭔가요?
Yeah, I mean, well, so just to add more to it, the interesting thing about kind of like hardware life cycle is what you see is probably like trailing by 8 months, 6 to 8 months. Everything that people have publicly seen is kind of like very old progress. Actually, we've made significantly more progress since then. So some of the stuff we'll show in the next couple of months have been in the works for like last 12 months or something like that. So yeah, definitely, I think like the team is very hardworking and has been able to execute at a very fast clip. I mean, the reason for that is, I think, one, generally, Foundation has very high talent density. So we have people who have been working in this space for a very long time and have really good perspective on what design decisions and bets to make. Second, we're very disciplined in what we do. So we don't try to do a lot. We focus on a few things and we just do them really well. And then third, like, there is no substitute for a lot of hard work. Like, we are pretty much working 6 to 7 day weeks all the time. So like it's a lot of hard work. You can come here at like 8 p.m., 9 p.m. and you'd still have majority of the team working almost all days. I do think just the culture is also much more rapid. And like people ask me the question like why is it important to do that? And when I started Foundation, like my core, the thing that got me really excited was I think robotics can help build like cities of the future. So housing, infrastructure, farming, all of the logistics, defense. I think we're very close to being able to build cities bigger than Seoul, bigger than New York, bigger than London at a fraction of the price. The whole idea that there's scarcity is actually quite false. Like, there's scarcity because creating new cities and building new infrastructure is very expensive. But if you can really reduce the cost of doing that, then there's no housing scarcity. There is no food shortage. There is no great education shortage. There's no great medical attention shortage. All of those things that are like basics outside of just the fake construct of consumerism, we already have in abundance, from energy to food to land resources. So I just cannot, like, it really charges me up to be able to think that one day Foundation will be building cities that are bigger than New York, and we just have a high sense of urgency of getting there. We really want to be able to get there as quickly as possible. And the only way we can get there is phase one is scale and become profitable. So why we're working this hard is because like we cannot wait to get to the starting line. For us, the starting line is that the company is now profitable. and then all the profits are being poured into building all technologies needed to be able to demonstrate that these robots can build very large cities at a fraction of the price. So that's what's driving the sense of urgency, and that's essentially the mission. Like the mission here is we want to create technologies that make life self-sustaining, initially on Earth, then beyond, so Moon and Mars as well. And like I cannot wait for that to be the case. So like we just cannot wait, and that's why everyone's working this hard because we want to get there as quickly as possible.
휴머노이드 로봇이다 보니까 어쨌든 그 노동력을 대체하는 게 1번 과제인데 그 만들었을 때 가장 먼저 경제성이 나올 만한 국가, 타겟 국가가 어디부터 좀 생각하는지 좀 궁금합니다. 예를 들어 러시아 같은 경우는 노동력이 저렴하기 때문에 로봇과의 가격 경쟁력이 조금 힘들 수는 있는데 미국 같은 경우는 워낙 인건비 높으니까 여기도 시장성이 훨씬 경제성이 좋아 보이거든요. 그런 점에서 미국이라는 시장을 1번으로 보는지 아니면 아시아를 1번으로 보는지 이런 게 좀 궁금해요.
I do think at the very beginning this technology will be in areas that have big labor shortages, or labor is very expensive, or has declining birth rates. So usually it's a combination of all three, which I think creates this scarcity where if you don't have enough labor, you cannot produce enough goods and services. So like there's a reason we haven't focused on farming, which is like kind of part of our core vision in the future. We also want to do farming, but that's because the unit cost needed to be able to make farming economically feasible to be done by robots, the price the robot has to come down in a big way. While that is not the case for defense, logistics, auto manufacturing, the cost of labor over there is quite expensive already, and there's a severe shortage of labor as well. And that is true in the US, that's true in Japan, that's true in Europe. I believe that's also true in South Korea. So in a lot of places that is very true. If you have very cheap, abundant labor, it might be that you do not need this as a solution in the short term, but you would still in the long term if you want to grow the economy in a big way. But right now, a lot of the target focus for that reason, that's why has been these regions where there are labor shortages and the cost of labor is quite expensive.
지금 휴머노이드 로봇으로 이제 뛰어든 회사들이 많은데 뭐 대표적으로 테슬라의 옵티머스, 현대 뭐 보스턴 다이너믹스의 아틀라스 이런 곳들과 지금 이제 파운데이션 봇은 어떤 차별성을 두고 있는지가 궁금합니다.
I mean, a part of it is I don't think we're really in competition. Tesla is very focused on home use. Boston Dynamics is very focused on light industrial use. We're very focused on defense and heavy industrial use. So the robots we want to build, we want them to be able to work outdoors and do very heavy duty work. And from as far as I can see, no one else is making those robots. For the longest time, I thought people weren't making those robots because they thought the technology could not, you didn't have the technology at a place where you could build them. Last year and a half have demonstrated to me that's far from true. I think you can build really strong, robust robots that can work outdoor. So I think I would infer that people are just too afraid to build big robots, like at the end of the day, because they look pretty intimidating. So they are kind of like in their competition in terms of like engineering, but when you look at really our market focus, we're not really competing with them, and I don't think we're competing with anybody because like I'm not aware of another humanoid company that is doing actual focus on heavy industrial, and they have very different design choices. Like you have to prioritize things like waterproof, dustproof. You have to prioritize policies that are quite robust to being perturbed and the robots still being able to walk and balance themselves. You have to also focus a lot on building robots that can do high payload capacities, and none of those things are core focuses for Tesla, Boston Dynamics, and other humanoid companies. They're very focused on either light industrial work or at home work, and all the design choices we've been making have been very much so to be able to do heavy industrial.
그 휴머노이드 로봇도 보면은 어떤 회사 거는 손가락이 3개고 여기 회사는 5개인데 손가락이 5개여야 되는 이유가 무엇인지 좀 궁금하거든요.
I mean, the key reason is you want the robots to be able to use the same tools humans have been using. So if you want them to use the same tools that humans have been using, they by and large have to have similar degrees of freedom in their hands. There's just like no way around it. The only alternative to that is either you remake all tools or you make a bunch of different hands. A bunch of different hands means every single team has their own SKU, and you have to staff that up now because every hand is going to have some work cut out for itself. They're all going to have their own supply chains, so you would not get the cost benefit. They're all going to have their own manufacturing processes, much harder to scale. And I think it's like, for obvious reasons, very impractical to expect all tools to be rebuilt for the robots. So that means you won't grow as quickly if the latter is also true. So just like it makes sense. You have like I think you just have to bite the bullet and make a hand. There's just no two ways to it, because if you don't, you're hitting your ceiling in terms of what you can do. And we think, I'm of the opinion, again, the same concept about being able to move fast. We can make one of a really good thing versus 5 really good things. So all of our eggs are in the basket of a highly dexterous hand, which means it's one team, singular focus, one supply chain, and that's the path to success. And we just have to work really hard to make sure we can actually build something that's really good there. But that's essentially the idea.
이제 로봇이 계속 이제 발전되다 보면은 차세대 넥스트 모델이 계속 나오게 되는데 이때 이제 하드웨어적으로 가장 힘든 문제점은 뭔지 좀 궁금합니다.
I mean, it's a great question. I think for the last year and a half, the most difficult part was actuators. Like the robots are by and large actuators. And the task we had cut out for ourselves was we needed to be able to build an actuator that could survive high impact, which industrial actuators are not really good at. Like if you actually throw an industrial arm down from its tabletop, the likelihood that it's going to work is very low. Because those gears are very sensitive to high impact. And a humanoid is just impacting with the environment all the time. So building actuators that are quite robust is tough. Building actuators that are quite robust and waterproof is tougher. Building in actuators that are quite robust, waterproof, and easy to manufacture is even harder. Building an actuator that is robust, waterproof, easy to manufacture, and high vibration tolerance is even harder. And then we had to like go through all of those gates and do it. So like for last year and a half or so, building a very reliable robot actuator was the biggest hardware constraint. Now the biggest hardware constraint is the highly dexterous hand, because that's still a mechanical and electrical engineering challenge that needs to be solved. So we're working quite non-stop on that. So now I feel like with both of those, you have almost all the building blocks of what I would call is like the hardware is at par or better than what humans are. And then all of the bottlenecks get moved up to manufacturing and AI. And then I think I see some subsequent models like Phantom 3. We're probably going to, I'm sure we've over-indexed on things that we overbuilt for Phantom 2. With more data, we'd be able to reduce them down. Reducing them down would bring the cost down on those areas, make actuators and motors more efficient, make compute performance much efficient, which means now you need a smaller battery than you need today, which is 3 kilowatt hours today. And then you have a robot that is more optimized for what happens on a day-to-day basis. And then for Phantom 3, we would also want to design a robot that robots can build. Phantom 2 is a robot that humans build, and it'll be a mix of humans and robots building it. Phantom 3, you solely want to build a robot that is very easy for robots to put together. So those are kind of like, now we're getting pretty close to, from a hardware perspective, your biggest constraint and your innovation is going to come from going from overbuilt to adequately built, and going from kind of like going as exponentially down as you can on manufacturing ease, which makes it so you can build a lot of them. So that's first. And then second, Skywalker, which is the high dexterity hand, is one generation behind from that. So over the course of the next couple of years, the goal with Skywalker would be to be able to get it to the same place. But right now, we solved like some pretty key mechanical and electromechanical challenges with Skywalker in last year, technically less than a year, so in the last like 6-7 months. We have some more R&D challenges we have to solve for in next few months, and then we have to make it more reliable and easier to be manufactured. And from there, it's the same thing. Whatever it's overbuilt, right, build it, build something robots can put together, and then you scale from there. But those are like, by and large, the big challenges. Then you're going to have a lot of variance. So for instance, Phantom 2 is quite strong, which is about 80 kgs bicep curl. So it can do about 80 kgs payload. I probably envision like, I don't know if that's Phantom 4 or 5 or maybe like Phantom 3 XL. I think you need to get closer to a ton. So you also need very big humanoids, especially in construction. So we would try to attempt something like that as well. But that comes with like its own unique set of challenges.
그러면 앞으로 이제 팩토리도 있고 물 로지스틱스도 있고 국방도 있는데 이 중에서 가장 먼저 큰 매출이 어디서 나올 거라고 보시는지 궁금하거든요.
We're currently pretty much split between defense and commercial. So it's close to 50-50 on contracts that we have. I'm sure that number is going to move one way or the other, but that's roughly how it's dividing up right now. The tasks are very similar. So the stuff they want us to do, with the exception of like maybe like frontline deployment or reconnaissance, majority of the stuff that is being asked to do is quite similar to what we would do in industrial settings as well. It does seem like the contracts do break down about 50-50 right now today between both.
그 중에서 가장 우리 회사에 돈이 될 것 같다는 거 분야는 뭘 먼저 보시는지 궁금합니다.
It's a tough one. It does require, the current trend continues, there is definitely a high emphasis on national security and defense. And if that trend continues, I do think our defense revenue would surpass our industrial revenue in the short term. We also have other product lines that we don't publicly talk about. The majority of the contracts that are coming in there are also defense. So I think defense will, in the short term, grow in proportion than industrial.
국방에서 휴머노이드 로봇이 쓰이는 게 이제 상상이 안 가는데 이거 어떤 역할들을 할 건지가 좀 궁금하거든요.
So there are a couple of like key use cases. Some of them that we've also demonstrated in Ukraine. One is supply logistics. So today human soldiers go out and pick up supplies and come in, and in Ukraine you get shot at when you do that. So they would prefer robots to do it instead. We've also done pilots around drone inspection, because again, drone inspection also happens in a somewhat precarious place, and it's very hard to find people who want to do drone maintenance in a war zone. So that's one of the other use cases. We've also demonstrated weapons handling, and the other two big ones. Weapons handling is more so proof of concept than actual use case, in my opinion. Maybe Mike would disagree, but the other two big ones are frontline deployments and then also reconnaissance, which is being able to breach a building. So go inside a building, go all floors, map that building so that when a soldier is entering that building, the building's already fully mapped out, because that's where most of the fatalities or injuries happen for soldiers, which is you're going into a building that is an unknown environment, and you don't know who's where. So those are by and large the use cases. I do anticipate we will see more of frontline. Again, it's a little bit dynamic. It depends on what's happening in the world. But if the current trend continues, I do think we will see more frontline deployments and more reconnaissance, and then some obviously supply logistics, and then further reduction of the other kind of logistics tasks that I mentioned.
그러면 예를 들어 뭐 기술적으로 톰 크루즈 같은 형태로 이제 만들어낼 수도 있지만 이 윤리적인 문제 때문에 이제 그거에 투입되지 않고 이제 비전투 형태로만 활용하는 게 지금 보는 시장에서의 관점이냐 이렇게 좀 묻고 싶네요.
So if you look at the history of warfare, we had significantly more collateral damage in World War I and II than we have in recent wars. And primarily that is because since World War I, weapons precision has significantly increased. Drones are more precise than land and air invasion that historically we've done. And I think it's like our moral imperative to make more precise weapons. Going in, bombing a building because you want one person in that building is pretty high collateral damage. Obviously significantly less than what it is in history, but it's still pretty high. We think it would be significantly better if you have more land-based autonomy so that you can breach the building and go directly to your target versus civilians that are involved as well. So I'm generally quite supportive of land-based autonomy that is weaponized by the time that you have humans in the loop. There will be scenarios where you would not be able to have humans in the loop, which we today have already with anti-drone missiles and things like that, where the likelihood that if you don't take an action, there is 100% a chance of fatality. You have to take autonomous action to prevent that from happening. There are scenarios like that that just apply to land-based autonomy generally. So I don't want to draw this line where it's like, well, you can never have fully autonomous weapons, but majority of the use cases would be with a human in the loop. But you have a room to get significantly more precise and avoid even further collateral damage. So I think that's generally a good thing. I think it's actually quite immoral to not do that.
휴머노이드의 가격은 나날이 내려가고 있고 노동 비용은 나날이 올라가고 있으면 어느 시점부터는 휴머노이드 로봇을 쓰는 게 더 경제성을 띠는 시점이 오는 것 같은데 이제 파운데이션 봇 회사에서 봤을 때는 이게 언제부터쯤이라고 보는지 시기를 좀 예상하는 게 있는지 궁금합니다.
It's already the inverse, at least in the US. And I know for a fact that is also true in Japan and a couple of other countries where the cost of labor is already more than what you would lease the robot at. For instance, in the US, a fully loaded factory worker is anywhere between $50,000 to $60,000. One robot does the work for 3 workers because it can do 3 shifts every day. So that's anywhere between $150,000 to $180,000. We lease the robots for $100,000. Phantom 1, it costs us to make them for $100,000. So our payback period is 12 months. Phantom 2, it costs us to make it at $50,000. So our now payback period is 6 months. But the cost is kind of like the same. So even today, there are countries where I would actually say that the price equation's already switched. And I think you're probably a decade so away from that being the case everywhere, because one, the cost of the robots are going to come down quite exponentially, and there are now labor shortages across board, which I think we will start seeing the impact for in next 12 to 15 years. At the most, we have 30 years to be able to close to fully automate all key aspects of our industrial base, or we will be in a lot of trouble. The halfway point to that is about probably like a decade or 15 years. You would have already flipped the equation across the world.
그럼 여기 파운데이션 봇의 이제 넥스트 모델에 대해서 공개할 수는 없지만 뭐 숫자로 좀 보여줄 수 있는 것들이 있는지 좀 궁금하거든요.
Yeah, for sure. So the current robot Phantom is capable of doing about 30 kgs continuous payload, bicep curl, so like rice bag, and it can withstand about 12 Gs of transient force. So that's vibration, and that comes with falls or just even walking. Walking creates a lot of vibration because robots have no soft tissue. So it's kind of like if a skeleton's walking. So it's a very high vibration system. And today it essentially doesn't have a battery. We're about to put in a battery pack in there, but that's like about an hour and a half of battery. Phantom 2, and also it's a much harder robot to manufacture. Right now, we build about two every week. How I said, Robo Factory 1. Phantom 1 is about like 5'10", so Phantom 2 is about 6 feet, can do about 80 kgs continuous payload, has about a 3 kilowatt hour battery, which gives it close to 6 hours of range, is waterproof, dustproof, can survive about 100 Gs of vibration, so you can technically strap it on a rocket and send it to space, and its electronics would not break, so its PCB boards and circuits wouldn't really break. So definitely like significant orders of magnitude improvement on all kind of the key benchmarks that we care about.
제가 좀 들어보니까 팬텀 2면 바로 그냥 나오자마자 현장 투입해도 되는 정도 아닌가 싶거든요.
We'll build about 10 of them in Q2 just to be able to validate and kind of improve any of the quality issues. But yeah, the robot's like complete and now it's being brought up. I don't think there's anything else like it today in the world. So when we unveil it to people, I think it's quite a special robot, and our goal is to start scaling that in Q3. And we want to do like hopefully thousands of them this year.
그러면 이제 회사의 앞으로 이제 좀 향후 계획을 좀 숫자로 표현할 수 있는 계획들을 한번 말씀해 주시면 좋을 것 같아요.
In the next few years, our goal is to really scale from current size to about 30 to 40,000. We want to deploy close to 30,000 robots next year, a few thousands this year. And then we want to scale that upwards of 70,000 the following year, maybe 100,000 if we really can. While very soon, we're going to start designing Phantom 3, which is the 3rd generation robot. It's going to be a build on Phantom 2. We'll obviously optimize some things that we think don't make sense to have overbuilt, and then design the robot from ground up to be a robot that is very like easy to manufacture with just robots. So Phantom 2 will be manufactured in Robo Factory 2, which is what we're building this year. It's a second factory. Robo Factory 2 would be about 200,000 to 300,000 square feet. Robo Factory 3, which will build Phantom 3, we think would be close to 2 million square feet. We'll have significantly less human footprint. So by and large, it would be robots building robots. We want to do that next year. So that's essentially the goal. We're also in the process of taking live our new compute cluster. So that's about 800 Blackwell chips, and that would be by and large used to train Cortex-2, which is a second generation AI that we're launching with Phantom 2. Then after that, the goal is to close to like a little over 10x, so 8,000 to 10,000 Blackwell chips for Cortex-3. That's our third generation AI. Yeah, so those are kind of like some of the near-term things. We definitely, like if 5-6 years down, we do see ourselves making like upwards of 300 to 400,000 robots every year.
지금 공장을 그러면은 애플처럼 그래서 기획만 하고 생산을 뭐 대만이나 아시아로 외주를 줄 계획인 건지 아니면은 공장도 그냥 테슬라처럼 미국 내에다 짓고 생산할 계획인지 이거 좀 궁금하네요.
Robofactory 2 is in the US, so we're building that inside the US. We expect Robofactory 3 to be here as well, probably, however, in like much more remote parts of the US. We will probably do manufacturing in other parts of the world as well, but that would be more so to be able to serve local demand than to serve demand in the US. I think for the US demand, we'll continue to build here. It's also important from a defense contract perspective to be able to build those here as well for US defense.
아까 GPU로 이제 그 블랙을 얘기를 한 거 보니까 이 하드웨어도 판매가 되지만 이제 앞으로 로봇의 그 브레인은 계속 이제 업그레이드가 될 거 아니에요, 브레인. 그러면서 이거는 어쩔 수 없이 아마 구독을 하지 않으면 효율이 나오지 않으니까 이제 이거를 계속 구독을 시킬 것 같은데, 그럼 이제 구독제라는 게 혹시 하드웨어는 팔고 이거만 구독을 할 건지 아니면 하드웨어도 구독이고 이것도 구독인지 좀 궁금합니다.
I think it's going to, like, in the near future, it's going to be hardware, software combined as a subscription model. I think in the future, like when we're approaching Phantom 3, I think it's going to be just software subscription, and hardware upgrades would be similar to how they are with your phone and your cars, which is if you need more capability, you just buy a new phone. We think a lot of the capability we will deploy with Phantom 2 in terms of raw compute available on the robot is quite sufficient to be able to do the kinds of tasks these robots need to do. Obviously, there would be more advanced tasks the robots would do over time that would need more compute, but that would come with hardware upgrades that people can choose to get if they would want those capabilities. For instance, one big upgrade in Phantom 3 would be you would have real-time multi-agent orchestration. So a bunch of robots can work together to do one thing, one goal, task. That would definitely require more compute than what the robots have on them today. So things like that definitely would be hardware constraints, but then you solve for that as packaging them as new capabilities and new models.
그러면 올해 파운데이션이 반드시 증명해야 되는 한 가지가 있다면 무엇이라 생각하는지?
That we can scale deployments. So I think that's the biggest thing. Phantom 2 and Cortex 2 are by and large designed to be able to scale. So it's a function of actually doing it. So I think this year the biggest singular focus is scale Phantom 2 and Cortex 2.
오늘 인터뷰하면서 느꼈던 거 뭐냐면은 이 CEO님이 처음부터 질문 끝까지 일관적이고 되게 하나의 비전을 계속 보여주면서 이야기하는 덕분에 로봇이라는 사업이 되게 현실적으로 다가오고 있고 앞으로 우리가 보지 못하는 세상이 금방 열리겠구나라는 게 느껴지는 시간이었던 것 같습니다.
I think there's definitely a dissonance where the rest of the world doesn't fully comprehend the massive technology acceleration that's about to come. That is both true in robotics, but also just digital AI. How we work, what we do is going to significantly change. I'm not of the opinion that that change is going to be that humans have nothing to do. I think it's going to be quite exciting instead. I think what's going to happen is right now, majority of our focus when we work on the robots we're building and our peers are working on digital AI is how can you have one person 10x their output. So, and I think that's the more sobering real impact today, which is we think across board one worker is going to be able to do work of like 10, 15 people. That is, robots are going to make that true in the real world, and digital AI is going to make that true in the digital world. So I think generally that's kind of the big step function improvement, and I don't think most people realize that that is going to happen relatively soon. It's already starting to happen in much more different fields that are closer to the valley. Like software is completely disrupted. You barely write any code, but you still produce a lot of results. So it's not that like people are not hiring software engineers. It's that now one software engineer can do the work that 10 would be able to do. So I think, yeah, some of the stuff is much more near term than people realize.
저는 투자할 때 CEO를 많이 보는데 CEO를 만나서 대화를 해보니까 이 회사 빨리 투자하고 싶은데 뭐 바람이 있다면 빨리 IPO해서 빨리 상장하시길 바라도록 하겠습니다.
Oh, yeah. Thank you. Thank you.
오늘 마치도록 하겠습니다. Thank you so very much. Yeah, thank you.